Now let's begin part 2, the main part of this lecture. We will introduce the network reference model and the standard protocols in each layer. First, let's look at what is the OSI reference model. Actually, the whole network includes a lot of different pieces. We cannot learn every detailed bit. Actually, we can divide them according to certain criteria. So according to what they are doing, the main functions, the whole network can be divided into several different layers. Each layer do one core function, and the lower layer, for example, the physical layer, interact with the real physical world. For example, they put 0 and 1s on the cable or on the wireless media. And the higher layer actually interact with users. So when we use applications, we need to send some message, receive some message. So that kind of function are done by the application layer. And then each layer provides certain service for the upper layer. And the upper layer's service actually rely on the lower layer's service. So that is the key model of the reference model of network layers. Actually, we can divide the whole network into 7 layers according to OSI reference model, or we can divide that into TCP/IP reference model, which only include 4 layers. So actually, in computer network or in the internet, people typically use TCP/IP reference model. That is this 5-layer reference model. So the upper layer is the application layer. Application layer protocols defines the format of message, which is used for the applications to transmit the information, the data into the network, and receive the message from the internet. And the application layer will transmit or receive these messages. Then we need the transport layer to transmit the message from end to end. For example, if here is the transmission computer, here is the receiving computer, the transport layer of the transmitter will receive a message from upper layer and then add some header and then transmit down into the next layer. And the transport layer provides the end-to-end transmission. Especially if we use TCP protocol, they will provide the reliable end-to-end transmission. And the transport layer, there is network layer. The transport layer only exists at the end, at the sending computer and the receiving computer. But instead, network layer exists in both end system and the routers in the network. So, and network layer provide the routing. They will select a best path for the data to be transmitted in the network. And each router's network layer actually will receive some packet. And according to the destination, they will forward the packet to the correct next hop router. That is the function of network layer. And then below network layer, that is data link layer. You can think of the data link layer to provide the one hop transmission. And then finally, the physical layer translate the 0 and 1s into some physical signals. For example, they transmit into the electromagnetic signal and send them into the open air. Then there is a wireless media, that is the wireless transmission. And through the physical layer, one node can transmit some data to the neighboring node. That is the 5-layer model. Common TCP/IP protocols include the following typical protocol. For example, in application layer, when we use the web browser, we need to use HTTP protocol to access the remote web server to download the web page. And if we want to transmit some file download or upload some file from the server, we need to use this FTP protocol. We also need to use this DNS protocol, which is the domain name server protocol, to translate from the server's name from the host name to the IP address. Also, we will have this DHCP protocol to dynamically configure the IP to the host and routers. And for transport layer, there are only two typical widely used protocols, the TCP protocol and UDP protocol. The difference between TCP and UDP are the UDP only provide transmission, but they cannot guarantee the performance. In contrast, TCP can provide the reliable data transfer from sender to receiver, meaning that TCP can guarantee the sequence of each packet, and they can guarantee that there is no error in every packet. As for the network layer, all the network devices need to run this IP protocol, Internet protocol. This is the key of this TCP/IP protocol stack, or the Internet. And above IP protocol, there are two management protocol. One is the Internet Configuration Message Protocol, which will send the control message. And another one is the Internet Group Management Protocol. They will manage the multicast groups. As for the data link layer, actually there are a lot of different protocols. So for example, the Ethernet are used for the wired local area network. And for PPP, that is a point-to-point protocol that can be used in the end-to-end direct transmission. The last layer is the physical layer. For physical layer, we have much more different protocols. For example, the L2.11, the L2.3, the satellite, the TV, and a lot of other protocols. So actually, all the protocols can be divided into two parts. One part is standard. The standard are the protocols which are public. All the users, all the developers need to follow this protocol. That is called standard. And the other part is the proprietary protocol. That is owned and developed by a certain company. They may not publish this protocol to the world, and only the company know the details of the protocol. That is the proprietary protocol. A lot of protocols are standard protocol because in that case, all the devices, all the developers can follow the standard so that different devices can interact with each other. And the common protocol standardization organizations include the following three important organizations. One is the IETF, the Internet Engineering Task Force. A lot of protocol, for example, TCP, IP, DNS, DHCP are all defined by this task force. Another one is IEEE. IEEE defines the electronics and electric and computer science field standard. So the well-known IEEE L2.3 for the wired LAN and the L2.11 for the Wi-Fi are all defined by IEEE. Another one is this ISO, International Organization for Standardization. ISO defines not only the computer engineering, the computer network protocols, they also define a lot of other standards. For example, the ISO network model are defined by this organization.